Okay, so quiz 8, I believe, dealt with a function of this form, and we're asked for various limits. The limit as it approaches 0, the limit as it approaches 7, I think. So, alright, so the first thing we would do is we want to plug in those values into this function, but before we do, we notice, hey, wait a minute, there are absolute values present, which means it's a piecewise defined function. So I want to rewrite it in the form something, it's given by one formula if some condition is true on x for part of my domain. It's given by a different formula for a different part of my domain. And it's given by, maybe a different formula for a third part of my domain. How do I know there's going to be exactly 3? Well, we'll jump in a moment. So the question is, where do the junctures happen? So the junctures are precisely those values of x for which we change the formula that we're using. All right. In the absolute values, in the case of absolute values, the junctures always occur. So for absolute values, junctures occur wherever the insides of the absolute value signs are 0. For the absolute value function itself, it looks like this. It's equal to x for x bigger than or equal to 0. It's equal to negative x for x less than 0. So the juncture for the original absolute value sign occurs when x equals 0. So if we have the absolute value of something other than that, something like x minus 7, we have to ask ourselves, when is x minus 7 equal to 0? So I said the insides with an S of the absolute value signs because we have 2 of them here. So that means that we're probably going to have 2 different junctures. One because of this absolute value sign, and one because of this absolute value sign. Alright, so let me actually do one at a time to make it hopefully a little bit simpler. Let's worry about this first absolute value sign. If x is negative, so if x is negative, then the absolute value of x is equal to negative x, right? Negative 5, the absolute value of negative 5 is negative 5. The negatives cancel and give you the 5. So the absolute value of x is equal to negative x here in this situation. So I'm going to leave this other absolute value sign in for now, just for now. But this is given by the formula negative x minus 7 divided by the absolute value of x minus 7. If x is negative, because if x is negative, then that first absolute value is going to be negative x, because we're restricting our attention to this case. On the other hand, if x is bigger than or equal to 0, absolute value of x is just x. So that should be an x minus 7 on top over the absolute value of x minus 7. Okay? Absolute value. Which equals, let me actually move over. Which equals what? Okay, now I want you to notice something. If x is already negative, then subtracting 7 only makes it more negative. So for x less than 0, certainly x minus 7 is already negative. So when you take its absolute value sign, the absolute value of a negative number is just going to equal negative that number. Alright, the negative will cancel the implicit negative here. So I can actually get rid of those absolute value signs. In fact, I'm not even going to do it over here. I'm just going to do it right here. I'm going to get rid of those absolute value signs. And the formula doesn't change at all if I put a minus right there, because when x is negative, x minus 7 is certainly negative, so its absolute value is definitely going to be minus itself. Okay, so now we've gotten rid of the absolute value signs here. But what about here? Can I apply similar reasoning? If x is positive, what can I say about x minus 7? Let me draw the real number line. There's our real number line. There's 0. There's 7. Now, if x is positive, it means it's to the right of 0 here. So maybe it's over here, maybe it's over there, maybe it's over there, maybe it's over here, maybe it's over there. And what you'll notice is that if I'm between 0 and 7, x minus 7 is negative, because x is less than 7. So you're subtracting something bigger, you're going to get something negative. In that case, the absolute value of x minus 7 is, the absolute value of a negative number is negative that number. But at this shift, if x is bigger than 7, then x minus 7 is positive. And therefore, the absolute value of x minus 7 would just be x minus 7 by itself. Now, no need to multiply by a minus sign. There's no other minus sign to cancel. Okay? So what we're seeing is that, you know what? We've dealt with one juncture at 0, but there's another juncture here at 7, which makes sense. That's exactly the value of x for which the thing inside this absolute value sign is 0. Right? When you plug in 7, 7 minus 7 is 0. And that was the rule I said here. The junctures typically occur wherever the insides, whatever's inside, everything that's inside of the absolute value sign is collectively equal to 0. And that happens when x is 7. So we should add that as another condition. We already know the formula if x is negative. It's negative x minus 7 over negative x minus 7. What do we do if x is between 0 and 7, right? So that's another part of our range. So it's bigger than or equal to 0. Sorry, that should be an x. But it's not 7 yet. It's less than 7. And where these equality signs typically don't matter if you're dealing with absolute values. Well, in this case, the top is still x minus 7. So we have x minus 7 on top, because I'm using this bottom formula now. But the absolute value of x minus 7 is now, we're in this range here, so it's negative x minus 7. And then finally, we have another range. What happens when x is bigger than or equal to 7? Again, where I put the equality doesn't really matter here. And in that case, the absolute value of x minus 7 is positive, and this is positive, and everything is positive, and it's just x minus 7 over x minus 7. Okay, so now that we have these kind of nice piecewise defined functions here, we can start to answer some questions. First of all, notice that x minus 7 over x minus 7, which is the situation we'd have if x is greater than or equal to 7, do you notice that they cancel perfectly and that's the same as 1? So the function is actually equal to 1 here. I'm going to erase that and just put a 1. The function is equal to 1 whenever x is bigger than or equal to 7. And do you notice that here, when x is between 0 and 7, you have an x minus 7 divided by x minus 7. Look, whenever you have a over negative a, the a is canceled. That's just negative 1, right? So this is negative 1 in this range. So the function is actually equal to 1 when x is bigger than or equal to 7. And it's equal to negative 1 when it's between 0 and 7, because you're going to have an x minus 7 over negative quantity x minus 7. And then it's going to, is there any way we can simplify this? Not really. This is going to be negative. I guess if you factor out a minus sign from the top, negative x minus 7 is the same as negative quantity x plus 7. And then these minus signs will cancel. So you'd have x plus 7 over x minus 7. Okay, so that's weird. It's given by 3 different formulas depending on these 3 junctures. Now, the quiz itself asks us to check the various left and right hand limits as we're going to 0 and as we're going to 7. So as we approach 0 from the left, coming in from the left, that means we're taking negative values of x, which means we're using exclusively this formula, x plus 7 over x minus 7. So we just plug that in, x minus 7. We just plug in 0 here. You're going to get 0 plus 7 over 0 minus 7. You're going to get 0 over negative 7, 7 over negative 7, which is just negative 1. So the left-hand limit as we approach 0 is negative 1. What about the right-hand limit? As we're getting closer and closer to 0, eventually we're going to dip below 7, and we're going to be using this formula exclusively, which we've already seen simplifies to negative 1. And so it doesn't even depend on x. This is certainly going to equal negative 1. So what we've just seen is that as we approach 0 from the left or right, for different reasons, because different formulas are being applied, we're still going to get the same answer. They're still going to approach -1. So the limit as x approaches 0, and this is always what you want to do with piecewise functions. You always have to check the left and right hand limits separately first, and because they're going to involve different formulas at the junctures. So the limit does exist, and it's equal to -1, because the left and right hand limits exist. Okay, so what happens now as we approach 7, and we'll start coming in from the left. If we're to the left of 7, just to the left of 7, we're using this formula here. So it's just going to equal -1 coming in from the left. And of course, it doesn't even depend on x, that's just -1. What happens, however, as x approaches 7 from the right, we're using this formula now. That's just 1. Again, it doesn't depend on x at all, you get a 1. Now the left and right hand limits disagree. So the limit as x approaches 7 of this function doesn't exist, because the left and right hand limits both exist, but they disagree with each other.